Hmm. Get some green lights, got some streaming going on, that's very good. But what isn't very good is this error message on my screen. Uh-oh. Hello and welcome to CodeZone. Yes, it's been a few weeks and I'll fill you in on the details in a short while, but more importantly, oh no! Look at this error on my screen. This is no good. It says an error occurred in editor test polygons while attempting to open testpolygons.cpp. In fact, the file simply isn't there. It's been phantom removed. It's not even like I've accidentally removed it from the project, because it's still there in the project. If you selected the delete option, it wouldn't be there anymore. Now, this is a problem because it had all of my my test polymorph code in. However, never fear. It turns out that if you, because I store everything on OneDrive, I can actually go back in time and find the most recent version of the file. But it took a bit of time because it's not called the same thing. It gets called a .cpdp file for some reason. And there it is. So I did actually manage to salvage all the code. So we'll restore some of that in due course. So firstly, hello everybody. Yes, sorry it's been a little while. Apparently my bitrate is unstable. Is everything coming through okay? I've not dropped any frames at least, and it seems okay. Maybe Twitch is just expecting more these days. So something's gone wrong there. I guess it's part of the OneDrive synchronization procedure. It just went wrong one day and decided to nerf the file I was actually using. Yeah. Good. So at the moment we've just got Standard Int in the chat. There's nothing wrong with that. I like talking to Standard Int. He seems like quite the gentleman. Oh, Speedy, hello, good to see you. Yes, it's been a few weeks now. Last time we met, I wasn't very well. I had bronchitis. That's all okay. But since then, we've had family turmoil, we've had job losses, we've had new jobs, we've had family illnesses, we've had lawyers, we've had industrial tribunals, we've had all sorts of interesting things going on. And I'm not going to get into all those private details, but the other big thing, why have I not streamed for the last couple of weeks? Well, we got X10, well, the first grown-up bed, and they're doing a little bit of wandering around the landing now. So I'm having to be a little bit more subdued now they can escape. I don't want them coming in during the stream. So it's really only that reason. So we're trialing something now. I'm hoping we're not going to wake them up. Pliskit, hello. Yes. Trousers, hello. We've got no Magetsub today. Oh dear. Oh, maybe he's run off. So... what have I been up to? Well, if you recall, and sorry it's not syntax highlighted right now, we were in the middle of creating a sort of flexible polygon type that had temporal changing properties. And we implemented all of the animation framework and we started to have a look at how could we draw these things. And we, just to remind those, perhaps a few people don't remember, I took it away from the graphical user interface thing just to simplify the problem. Now, classic one-lone coder mistake is basically that meant starting a new, slightly different project. Which means you then get carried away with that project and sort of lose sight with what it is you were doing in the first place. And the same thing has happened again. Whilst I make an effort to restore this file, because I don't know how to change the name of it, I can't think I can do these things through, can I? It's in the wrong place. Let's have a look. Where's this? It shouldn't be there. Let's pull that out of there and stick it in here. Oh, apparently that file already exists in the destination. See, it's all very weird. Look, oh yes, it's there. Look at that. Interesting. Why did that sort of go to a strange name? Maybe it was, I don't know what's happened there. Yes, so I don't actually need to paste it. The saved file is already there. Good. Well, that is good because hopefully it means... test polygons is still not there. Why is it not there? Oh, no, skip that now. I don't want to copy anything over. That one is still there. It should be there. Something weird going on here. Now let's just close it down and try and reopen it. Maybe Visual Studio is not being very smart. There we go. That's nice. Oh, is that the right one? Yes, that's the right one. Good. Lumic code. Well, welcome. Hello. I don't understand emotes, and I don't understand what look like anime emotes either. I'm too old for this sort of thing. Alice, hello. We got colours again. Yes, sorry about that. So, you may recall we were bouncing polygons around, and it occurred to me that, well, to really sort of make this do what I wanted it to do, and that was to explore this polygon type, what was the purpose of the editor? Well, the editor was to push the development of Pixel Game Engine 3. Now, I've been keeping that fairly close to my chest because I know people are still using Pixel Game Engine 2, and as soon as you say there's a third one, they'll stop using that one and wait or whatever. But there are some features from it already that I wanted to start incorporating. And so I thought, well, how can I do this using the Pixel Game Engine 2 framework that I've got? Well, I went ahead and created a utility file, which basically presents the user interface and user interactions and all of those mechanics of Pixel Game Engine 3, but fundamentally uses Pixel Game Engine 2 to do the interface and the rendering. Now, there is a huge performance penalty for doing this, but it's good enough for me to actually check that things are working the way I was wanting them to, and it turns out they weren't. So this is actually a really quite useful thing that I've done. It turns out also this is quite a large file so far. It's one of these things, you just sort of get carried away with it once you start doing these things. But I thought we'd have a quick sort of look at what's actually going on in this file and why was it necessary to do it in the first place. If I go to the... let's get rid of this one now so we don't get confused. The test polygons file. We created this sort of polygon type. Forget the temporal properties for a moment, and we had to render it as a polygon. Well, then we wanted to start talking about transformations of these polygons, and I also wanted the transformations to have temporal properties, so we could start having animations. And it's starting to come together that actually what Pixel Game Engine 3 is sort of a vector graphic rendering framework, as well as doing all of the usual pixely things too. But I didn't have any of the transformation stuff in Pixel Game Engine 2. That was all in PGE3 and in the editor we've been working on. So I thought, well, I need that. Let's start bringing some of this stuff in. And then it snowballed, and then I started bringing in the pixel types, and then the vector types, and then the transformation types, and then the affine view types. And before you know it, I've got an almost fully functional Pixel Game Engine 3 plugin for Pixel Game Engine 2. So that's where we're at. Thank you, Alice. So, what does any of that mean? Well, let's have a look. So I've created a file called Pixel Game Engine 3 Experiment. Excuse me a second, usual cough problem. And at the top, I'm including this util. Now, it has to be included at the top, and I think I might release this in the near future, just as a utility. It'll be sort of for trials. It'll have some enable switches that you have to flick in order to get it to work. And it needs to happen before the Pixel Game Engine because it's going to overwrite certain parts of it. That's what the utilities and PegXs can do. But what it allows us to have then are these sort of more interesting properties which we don't have in standard Pixel Game Engine. We've got a TF2D, which is a transformation type. We can go and have a look at that. And we get this affine view. Now, if you've used Pixel Game Engine 2's transformed view, this is pretty much the same thing, but it starts having rotations. Now, that adds a whole degree extra of new problems. And you've seen me sort of whizzing the rotation stuff around plenty of times in all of the streams that we've done. But it does add some real problems because it means none of the traditional draw routines from Pixel Game Engines work. And since Pixel Game Engine 3 will fundamentally have an affine transform at its core, then the way that we structure all of the drawing routines has to be very, very different. No, I brought vector graphics to the PGE. Yeah, it's still going to do pixely stuff as well, but the vector graphics is because I feel one of the joys of playing with the Pixel Game Engine. I've seen a lot of people on the community doing this as well. Is how do you break? How do you implement more sophisticated looking things with very simple tools such as pixels and sprites? And that's fine for the most part, but it does mean sometimes the games look a bit inconsistent, they don't really work, not very scalable. And I've got in the back of my head a game project. I've had it for years. I'm not talking about it. I wanted to sort of get it out there last year. That didn't happen. maybe aiming for this year. It's probably not going to happen, but I'm building the tooling for it. But I do want a world which is very scalable. And so I needed all of these tools and rendering frameworks to help this happen. Good evening, Alex, if I've not said that already. Squashy circles. Yeah, there'll be some squashy circles, that's for sure. Tell me about snowballing. Yeah, that's the problem, right? Exactly. You start... Oh, Bixie's here. Sorry, Bixie, I didn't see you there. So that's exactly what's happened. You start thinking, oh, this would be a nice to have, and then before you know it, you're implementing huge swathes of functionality. So I created a little demonstration project. I posted a link to this somewhere. Maybe I can just go and grab that. Let's say I've got to use Discord search, so that's probably the end of the stream. Let's have a look. I'll find this link to where I posted some little demo of this. Scrolling. Oh, okay, there we go. Yeah, I've got the link. Yeah, it was in the PGE thing. What a delicacy. Hello, Magetsu. You're late. There's the link if you want to have a go yourself. There are some buttons to press, some instructions. I best post those as well, hadn't I? So these are the instructions. Right. Now, what does this do? Well, I can boot this up as well. Let's have a look. So far, fairly standard Pixel Game Engine 2 fare. There's some additive blending going on in the background, which looks quite nice. Somebody asks, is it shadery trickery? No, Pixel Game Engine 2 actually does have different blending modes. They're up for grabs. But yes, PGE3 will allow you to hook into shaders. That's actually really one of the core features of it. Now, Transformed View allows you to do all of this sort of stuff, which allows us to zoom in and move around. Now, you may notice something odd. We've got some outlines going on and things, and I think that's sort of... Is that symptomatic, or I don't know, what's the right word am I looking for? I don't know. It's a vector sort of art, as it tends to be quite scalable, as you can see here. Now, the images in here are actually textures, so ultimately they will become pixely, and they stay pixelated. As usual, you can have them filtered if you want. And if you hold down the space bar, we enter sort of disco mode, which I thought was quite nice. Sort of showing the different blending and different colours, but it's showing that everything is also rendered as a unique individual tile. Now, the change comes, and I've demonstrated this before, no big deal, when you hold down Control and move the mouse button, you can now rotate everything anyway. We'll have a look at what that is up there in a minute. And of course, because it's basically vector art, everything rotates nice and crisply. And I had this idea, well, wouldn't it be cool if we filled up this structure with balls and use the new Geometry 2D library to have them all bouncing all over the place, and perhaps you've got to get to a goal or something like that. It's irrelevant what the purpose is. It was just really me playing around with the drawing routines. You're late by a week or two. Oh, PG3. Sorry, Ask, since I'm a bit out of the loop. Is it still in development? Very much so, yes. You're looking at it. To be fair, what would run out first? Functionality, ideas, or computer resources that are needed to run them? This is a deep question. Well, that's what I thought, Alex. Yeah, it was going to be a bit like that. It's just sort of moving around. But really, it's a test of the drawing routines. And up here, we've got some drawing routines because we've drawn a weird shaded shape with an outline, and the outline has an outline, right? It's got meta outlines, or outlineception. And of course, it's complete. Oh, it's actually got several outlines because we've also got this nice glow around the edge of it too. And we'll have a look at some of the code for how this is constructed. So I guess this is the very first genuine Pixel Game Engine 3 vector art thing. And we'll have a look at all of this. The sky in the background is simply, I just wanted something other than a black screen. I'm fed up of looking at the same stuff. And if you're playing with things like additive blending, it's nice to have a sort of a texture in the background, so you can see what's going on. It's darker here, but it's illuminated in this case. wonder if it could render a fractal. Yes, it probably could render a fractal, but you'd probably delve. Well, actually, I was thinking a fractal outline might actually be an interesting thing, and we'll look at some of the limitations as to why that might be the case. Because if you start doing an outline of an outline, then of course you generate two outlines, and then if you generated the outline of those two outlines, you'd have four outlines. So eventually, you end up with lots of outlines. But let's have a look. How are we supposed to use this? And ultimately, now we're back on track, I think, with streams and sort of routine sets that. We'll see how the next week goes. Then we'll start getting back into the polymorph side of this thing, and then the transmorph side of this thing, and then we can start shoving it all back in the editor. But at least people have a way of creating the graphics. Another reason I wanted to sort of explore vector art is not everybody's going to want to use my editor to construct these things. And so it's interesting to look at alternatives such as Blender to create the artwork and potentially load things like SVG files and OBJ files, because it is all just polygon information in the end. But I might leave those sort of tools to the community should this gain a bit of traction. We'll see. Right, let's close that down for the time. So there's the map. So you can see it is actually sort of live generating the thing from tiles. So Pixel Game Engine, so this is here we go. On user update is Pixel Game Engine 2 through and through, because this is PGE2. But in the background, I'm running some PGE3 stuff. Ah, Londo, thank you very much. I appreciate you have a job again. Excellent, that's very good. Oh, I'm pleased to hear that. Is it something you want to do or something you have to do? That's the big question. Yeah, SVG loaders. Yeah, exactly, Bixie. Yeah, so I think we'll put outline. Sorry, I'm reading the other texts. I'm missing all this other chats going by. I've completely lost my thread of focus and concentration now. Sounds like we need... No, we don't use XML. We use OLC data file format, but what we need to do is create plugins for Blender that output that, and that's obviously the right way. Don't try and use other people's technology, make your own, right? So, affine view. Now, if we are used to using a transformed view in Pixel Game Engine 2, then some of this might look a bit familiar. There is a shortcut function called handle, pan, and zoom. Well, it's a little bit more complicated with PG3 because you can have pan and zoom, which is the case if you use the mouse wheel. You see zoom, but we've now also got the function to roll as well. The people are amazing, that's good. Oh, a nice and interesting word there. Reinvent every wheel. Yes, well, exactly, that's the one-lone code of philosophy. Now, there are some sort of loose ends with creating a Pixel Game Engine 3 plugin to Pixel Game Engine 2 because not everything binds up the way you'd expect it to. And as I said, there is a huge performance drop. So don't expect the performance to be indicative of what PG3 will be capable of doing. So PG3 also requires what's called a device transform. Now you can stack transforms, you can have multiple layers, and that's going to be necessary for the transmorph structures that we're looking at for handling the animations later on. But fundamentally, it's using the same structure of transform to handle displaying on the screen, sort of in screen space and in device space. It's quite nice that it works its way all the way down to the bottom, all automatically transformed. And so as I'm using a bit of a blend of the two, sometimes I'm using a Pixel Game Engine 2 function like this to draw the sky background, and sometimes I break into Pixel Game Engine 3 to construct the geometry sort of on the fly and render it at the same time. Now, all of these three loops here are to draw that tile map we've just seen. There's nothing clever here. I was literally making the code up as I go along. It could very well be sort of optimized a little bit. So to draw the tile, I'm drawing a filled rectangle, if it's a dot. What am I drawing this rectangle for? Oh, actually, that's to draw the white outline. So PG3, fill rectangle. Some of these functions will start to look very familiar. I've tried to keep a common naming convention. So I guess you can guess what that does. But of course, a rectangle in PG2 is always axis aligned. A rectangle in PG3 might not be. So you can't construct it and draw it the same way you would do in PG2. So that's why we have to now break everything into polygons, and if you've got a very sophisticated polygon renderer, you've got a very good vector art renderer too. So things we pass in, the position, the size of the tile. This particular function allows you to specify the 4 vertex colours. And you may remember that the tiles in the background had like a sheen to them. That's because I didn't have them all quite the same. There are variations of this function. So this one will just allow you to set a whole colour if you just want it to be simple like that. Yeah, wheels on the bus go round and round is very popular in this house. PGE3 are just a bunch of free functions. No, you still need to inherit from PGE2 at the moment, but ultimately there will be a PGE3 backend to do this that will replace that. But right now this is just a... so I want to trial what do these functions look like, how are they to use for the end user, and what is sort of the structure of an information flow through the system. As you can see, I've got a nice inline if ternary condition here to change disco mode or not. Draw rectangle, so you'll notice some commonality between all of the functions. In fact, have I got a nice list of these? I think I did. Did I create a nice list of these? Yeah, so each function type has draw, fill, and textured. So draw triangles, draws a triangle. Draw quads. Quads are an interesting structure because a rectangle is guaranteed to be defined by a top left position and a size. That's very useful, it's convenient. But of course you might actually want to draw a quadrilateral, which uses a texturing technique in a similar way to the Pixel Game Engine 2 did with its warped textures. That's actually a really useful tool for doing all sorts of pseudo 3D tricks, and that's why I want that to have a presence in PGE3. Draw rectangle, fill rectangle, and textured rectangle. There's now also draw polygon, fill polygon, and textured polygon, and draw circle, fill circle, and no, I've not done a textured circle yet. We'll come back to that. Right, so once I have constructed geometry, these don't draw straight away. In many ways in PG2, the decal is sort of the nearest equivalent, because all the polygons are actually hardware drawn. You can now choose when to draw that particular set of graphics that you have now constructed. So if you call this function, it will create the geometry and queue that geometry to be called. And this allows you to then draw things in a batch. That's very useful if you want to apply a particular shader. Now, we don't have that option in PG2, but the nearest approximation right now is you can actually change the blend mode. So you could, if you wanted to have one shader applied to all sorts of different drawn geometry, having this sort of manually called way of staging those draw calls, I think is a nice way to do it. I'll probably call it something a bit more user intuitive later on, so that function name may change. Shade line. Shade line, by default a line is a single colour. Shade line allows you to set the colour of the beginning and the end, and it will automatically blend between the two. Let's do it, let's stick one in. So let's do PG3 shade line. And we'll just specify 0.1. I'm picking some numbers out of thin air here, because we might not be able to see some of these, but we'll see. 100 by 100, and 0.2 we'll do 300 by 300. This could be huge. I have no idea how big this will be. 300. Now, in shade line, you've got to specify two colours. So let's say red and OLC green. And we're not tinting the line yet. So tint still exists from PG2. Let's see, does that actually work? Fingers crossed. Alter, hello. Right, so we have actually got a line there. Of course, it's only 1 pixel thick. Now, that's an interesting problem for Pixel Game Engine. When you start to use decals to render it, PG2 has always assumed that you just want to draw a 1 pixel thick line. PG3, I will sort of start having thickness as part of it, and that's really what the sort of stroke outline and everything's for. So you can see here that the line is green at that end, and it actually naturally blends over to red. In fact, all of the draw functions they have multiple versions where you can specify the colors per vertex, or you can specify the color of the whole thing. And in things like circles, you can specify the colour of the middle of the circle and the outline. So you can get sort of nice textured effects. That's exactly what I'm doing up here. See, I can specify this blue in the middle and a nice cyan around the outside. Why is this circle currently a squashed polygonal ellipse? That's because I was quickly throwing a test together before I came online tonight. So let's just go quickly down to fill circle. I'll explain how all of this code works in a moment. But let's just put the circle bit right, I think. What am I looking for? Polyformer. No, it's not polyformer. It's constructions. Generate. Fill circle. Fill circle. There we go. So I deliberately sort of hacked in here just to multiply by 2 because I wanted to see, can you actually draw ellipses, but I also wanted to see if there was some sort of biasing in a calculation I'm doing for the circle stuff. And let's turn this into a proper circle. If instead of drawing it as a 10-point rectangle, I'm going to just let it be a circle. Let's try that. So hopefully it might start to look a little bit cleaner now. There we go. Right, very nice. So I'm currently working on the stroke of this particular part here. That's why it's not quite finished yet. And you can see it's quite nice, right? And it's scale invariant, of course, which is very nice. Right? So these are things that you couldn't necessarily do in native PGE2. Would fluid simulation be very hard to do? Well, fluid simulation is one of those things that's traditionally quite hard to do, regardless of platform you're choosing to do it in. There are hacks and there are visually similar looking things, but it depends on what you need from it. Johnny G63, it's okay, you're only half an hour late, but thank you for the subscription. I've not got my headphones on today. If people have been following and things are happening and I've not heard the pings, I do apologise. Right, let's close that down and go back to what we were looking at. So yes, that's what shade line does. And you'll see there's actually a whole bunch of functions now. So draws, yeah, we've got them all. Loads of different ones that I've created. There is something interesting which will attract the real hyper nerds of Pixel Game Engine land. All of the functions, when you draw them, by default, it automatically queues them up into the PGE3 background. You can grab a handle of that if you want. So instead of having to regenerate the geometry each time, you can reuse pre-existing geometry. Now, why is that useful? Well, that's useful for exactly things like the strokes here. So let's just comment these two out, because these are a bit distractionary from what's going on. And yeah, I don't need... Yes, I do need that one. So why is this useful? Well, in this case, for this fill circle routine, I create the circle geometry. In fact, I'm just going to get rid of the strokes for now. There's nothing in the queue other than our shaded line and this filled circle, so nothing happens until we call draw queued polyforms. Let's just blast that out and see what happens. So there we go. We've got our queued circle. It's shaded in a particular way. Now, if I wanted to stroke the outline of that, I can use this stroke function. But I'm going to use it I can use it in one of two ways. So the first way to use it is I can just simply call PGE3 stroke, pass in the shape that's been generated, and it'll generate the stroke of that. By default, strokes are black, but I tell you what we'll do, just to make this a bit more visible, I'm going to set the colour to black, but with some transparency, so we can see where it sits in relation to the shape. Have a look. So this will, again, create a stroke geometry object and pass it through into the buffer. Now, hopefully you can see the transparency here. Do you know, I think what we'll do, just to make this a bit clearer, is if I get rid of the fade here, if I just change that to... I pick something really obvious. Blue to red. And I'm going to make this even more transparent. I want this to be really quite visible. Let's just pick 60 there for alpha. There we go. Is that even better? You can actually see what's going on. Don't think we can yet. Let me. Oh, it's because I've called Pixel F. I was wondering what was going on there. Why is this so vibrant? It shouldn't be Pixel F, just Pixel. Pixel F allows you to pass in normalized things. That's a PGE2 thing. There we go. That looks a bit healthier. Right. So what we can see is the circle here and our shaded stroke line. Why is our shaded stroke line also sort of gradiented? Have I put in two colours for this? Oh dear me, I've got to... Right, okay. I've been too clever for my own... for myself. Because you start realising you've got all of these capabilities, you start finding a way to abuse them. And that's exactly what I've done here. You can have gradiented strokes as well, so that's why I just wanted to... I'll put in the same colour twice. So you can have stroke on the inside and stroke on the outside. Let's have a look now. There we go. That's what I wanted to see. Now, the stroke, of course, is a polygon object in its own right. It's not just a bigger circle. But what we can specify on the stroke is we've got two parameters. We've got we pass in the shape, the geometry, and it doesn't matter what the geometry is. That we can change quite easily. And then we pass in the width of the stroke that we want. So at the moment I'm saying let's set it to 1 wide, but we'll offset everything by half. Let's change that offset to 0. Now, those of you that use Photoshop and similar will be quite familiar with the concept of stroke on your artwork and your geometry. So if I go and zoom in now, what we can see when the offset is 0, we've got half of the stroke on the inside of the boundary and half of the stroke on the outside of the boundary, just as you'd expect these sort of things to be. If I specify the offset to be 2, for example, look again. This time the stroke is, well, it's far beyond the edge of the shape, and this allows you to start being quite creative with the things that you might want to try and get. So that's how stroke works. Of course, we can bring stroke onto the inside of the object as well. But I can choose not to have the stroke polyform drawn straight away by using the generate versions of all of the same functions. So I can pass in exactly that. All this does is creates the geometry and allows you to have access to it, but it doesn't automatically queue it for drawing. Now, this might be useful if you want to sort of pre-compute lots of geometry at some point and reuse it, because computing the geometry alone might be quite time-consuming. But it allows you to sort of draw it as and when you need to use it. And in fact, if you did the same for this, so generate fill circle. I've not tried this, so this is a bit... Off we go, and all I do is choose to draw the polyform of the stroke. Is this going to work? Don't know. This is exciting. Might not work. There we go. We're just drawing the stroke on its own. So now you start to see there's a reasonably powerful linkage between these drawing and generate commands that allows you to create more interesting shapes based on what it is that you're trying to achieve. At some point in the future, I'd like to throw in some Boolean operations into the mix. I think there's some interesting material to talk about there. But you can start having shapes that you wouldn't have been able to typically have in PGE2 previously. Could you abuse stroke offset to create some kind of shockwave effect on something newly spawned in? Yeah, exactly. It's entirely animatable. How can we do that, do you think? Let's say we have our offset rates. Well, it's quite interesting. Let's try and hack that together. So let's have... well, we've got an F time variable. That's good. I don't think I'm using that for anything else, am I? F time is on space. It accumulates... I'll put in another one so we don't sort of mix these together. Let's have a go at a bit of a shock wave. Float. F shock wave. Time for the time being. We'll set that to 0. And if I hold down a key, we'll have another key. What should we have? Let's take that. If shockwave, I'm going to pick just the letter A, it's held, then we'll do F shockwave time. Shockwave time plus equals F elapsed time. Else, I'm going to set that back to 0 so we can sort of reset our shockwave. Shockwave equals 0. Let's start with something very basic. We just want to expand the offset based on shockwave plus 1. So let's just try that. So f shockwave time. Start with something very, very basic. And so if I press A... Oh, we chose the width, didn't we? We didn't change the size of the circle that it was based around. This might not be the best way to achieve this, but we can try this too. So we'll actually leave the width at 1 for the time being, and the shockwave should be 5 plus. Oh, shockwave time. There we go. So that's the radius of the circle that we're drawing around. Have a look. Sorry, I have to keep panning and zooming over there. Oh, press space. It's not space. Space is disco mode. That was disco, so it was a march. Right. There we go. So there is an increasing shockwave. We might want that to go a little bit quicker, perhaps. So times 10. Why not? Now, if you did want that to sort of fade out, then yeah, of course, you just play games with the transparency in this case. Which doesn't seem too bad. And you might actually want it to get a bit wider and dissipate too. Yeah. I'm just thinking if we draw the polyform with a multiplicative. Oh, this one. Decal mode is the best I've got for a shader at this point. Multiplicative effect. And we change the colour from black to white. I've no idea what that's going to do, to be honest. Let's just see what happens. This is half the fun. And this is why none of my projects ever get finished, is you just start sort of experimenting with these ideas and, oh hey, look at that. We must have had something queued up from previous. Oh, because we've set the mode, we've not set it back, right. Oh, press the wrong button again. So that's quite nice, the effect of the multiplicative on the background, and yes. And I think you're right, you probably want that to sort of fade out over time. So this is why I thought you get a bit creative and you start thinking, actually, there's all sorts of interesting things you can begin to achieve when you've got a reasonably easy to use animation framework. The reason I left the black and white in is to sort of give you that sort of faux lensing effect. Of course, it's not doing anything like lensing. There's no clever shading going on here, but it's a nice quick hack to give you what looks like a lens. You might want to make them less harsh as well, perhaps get them to sort of, I don't know, be a bit more transparent perhaps with what's going on. How many FPS do you get with release build? Currently it's sitting at, this is running at 330 now, this is a release build. It's running at 1280 by 720, and I've made no attempt to sort of stop it doing the PGE2 pixely things in the background. But like I say, do not take this as gospel, as performance. The way I'm actually drawing the polygons. Let's go and have a look at the code. Let's go and have a see what's going on. See this drawed queued polyforms thing. Obviously, it takes in a copy of the Pixel Game Engine 2 because it has to use that to do its drawing for now. This will change later on. It's a bit strange to sort of look at this function first, but it's actually maybe not a bad shout. So ignore the hard numbers you're seeing here. They don't actually exist. They're there for a reason. This is the function that looks at the queue of polyforms, called PGE3 polyforms, and then just sort of blasts them all out. But it needs to convert them into a format that Pixel Game Engine 2 natively understands. So that's what this is doing here. And this is a little trick, actually. I'll show you a performance increase, hopefully. So here I've got iterating through the loop. I need to store positions for each vertex, the texture coordinates of each vertex, the colours, and there's something called W, which is a warping factor. If you ever looked at the warped decal code, you'll realise there's an additional parameter used by in even OpenGL 1 to stretch textures towards points. Quite a complicated phenomena, but it's necessary to sort of avoid not perspective correction, but sort of triangular snapping of textures on quads. So it's actually quite an important metric to have there. And all this code is doing here is making sure that even if you've not supplied enough data in these points, that you actually end up with a consistent data set to ultimately go through and call PGE2's draw polygon decal. Now that's been there for quite some time now, and you've got to pass in a vector of positions, W's, UVs, colours, tint it, and you set the mode accordingly. So this is why there's a bit of a performance hit. So it's got to go through one layer of translation and then through to another. Well, at the moment, Johnny G, this will run without any changes, right? Because this is a PGE2 application, right? There is no sort of change to the PGE2 engine to make this work. There will be, however. So yes, you are going to have some work. So everybody, Johnny G has offered to, as he has done with PGE2, do a Android and iOS sort of version of the Pixel game engine, and that's very complicated, and for some reason he makes it more complicated by having it all done in mostly assembly language. But it's, whatever floats your boat. However, I think we'll support that a little bit better with PGE3. It's an opportunity to start to think about things like touch interfaces, multi-point touches. What if you do want access to things like the accelerometers and other devices in the phone? We've got to make sure Johnny G has something to do. So we'll make sure that happens. Now, why do I want to sort of show what am I doing here with these numbers? And this is really for sort of some of the beginners out there. If we look at it straight away, we can see it doesn't matter, by the way, how zoomed out you are. There's no sort of culling going on or anything. So right now, performance is running at about 320 frames per second, let's say. Why have I got these 256s here? These are not some upper limit, right? This is a vector. It can expand. The first thing I do is resize it for each polygon, because most of the time your polygons aren't actually going to consist of 256 vertices. But what I don't want to happen is a memory reallocation for every single polygon. When you resize a vector to go smaller, it guarantees, well, I don't think it guarantees, but I find it sensible that there are no implementations that actually then go and reallocate the memory. It's still there, and you can actually still grow it into that space too. If you do happen to go larger at some point, that's fine. You have to pay the cost of that reallocation, but that's why I thought we'll start off with a large number. And does it make much of a difference? Well, let's take out these hard-coded numbers entirely. If you didn't know, you can specify a vector to have a size from the start as well. I don't think any of them do. Yeah, could I make them static? Yeah, I could make them static. That's actually a good shout, Nagetsu. That might upset Johnny G. Let's have a look now. So without that optimization, yeah, it's about the same. It was more compelling on a different demo I had, and I thought it was worthwhile doing. So maybe it actually runs a little bit better without having the numbers there. But yeah, when I was sort of really sort of cranking out the polygons testing this, it did actually make quite a considerable difference to have these sort of ready-made, ready to go. So I'm going to put them back in. It was about the same there. I think the application's running too slowly anyway, and it's not the fault of this particular part. I think it's slow elsewhere, and it's simply because there's actually quite a lot of polygons being drawn now. So this isn't really anymore the slow part of the program. So yes, I'm really sort of bootstrapping Pixel Game Engine 2 to do some rendering, but let's have a look at how we actually do some of the drawing. And we months and months ago, when we started season 2 of the CodeZone, I did sort of introduce some of these functions. But it's worth having a look at the construction, a bit of a refresher. Fundamentally, there is a data type called a polyform. Now, that's not the same as the polymorph. It just sounds like we're making up lots of words here. But the polyform is sort of, it's not just a data structure, it's a data structure and an instruction at the same time. And so we can queue up this instruction and the data required to execute the instruction in a queue to send to a renderer of some description. Could be OpenGL 3, OpenGL 1, DirectX, Vulkan, software, whatever it needs to be. As before, there's a layer of abstraction between actually what's doing the colouring in and what's sending the data to it. But our typical polyform has a data type. We discussed those in a previous stream where we've got fans, lists, strips, individual triangles, points, that sort of thing. How many primitives are there? These are something to worry about in the future. These are the vectors of information for the vertices of that polygon. In this version, we have a single optional texture. In the actual PGE3 version, you can have multiple textures for multiple texture passes. We have the tint color, and we've bodged on here a wireframe option for the renderer to actually do the drawing. So when you call draw line in Pixel Game Engine 2, if you're not using the decal draw line, it will go away and use the CPU to draw the line into the screen. In PG3, that distinction has gone away. There's no longer really a sprite and a decal as such. The system is smart enough to know how to use the best to solve that particular problem. So in most cases, the lines you see drawn in PG3 are drawn in hardware. So we really are starting to beginning to leverage the hardware. And I don't intend PG3 to necessarily be source code compatible with PG2. At some point I have to put a break in. Here, because it's to hack for this PegX, I've got my transform for the device and the vector of polyforms. You could maintain your own vector of polyforms, I suppose. Now I have some different namespaces. I have a namespace called polyformer. And these are the functions. There's a variety of them for drawing, filling, and texturing. Doesn't matter what the shape is or anything like that. We've got to have something that forms the polyforms. So that's called the polyformer. And so that sets up these data structures as required, depending on the information that's given in. So here we've got draw polygon with vector of points and a vector of colours. But we also need a draw polygon with a vector of points and a single colour, in case you want all the points to be the same colour. Perhaps arguably that one's actually not necessary, but it saves me having to create artificially a vector here and expanding it out, depending on what the user wants. And here we've got fill polygons, a bit different. So you notice these ones have the wireframe option set to true because they're just drawing lines, whereas the filled ones it's set to false, there we go, because it's actually going to start drawing the shapes. And so there's actually only a handful of polyform functions, including these textured ones. There's also the oddball one, warped quad, which does this texture warping function that I talked about before. I'm not delving into that now. I've talked about that in, there's a whole video about doing texture warping, or dungeon warping, that was what it was called on the channel. I then have my generate namespace, and this is important because all my other draw functions will use this, so I'm trying to just have one function to do one thing, which is quite nice. So these, we'll come back to stroke, that's a complicated one. Let's come back to something a bit simpler. Draw a line, here we go. So draw a line requests that the polyformer is going to draw a polygon. It's a line. These are the coordinates, these are the colours, and that's the tint. Go away and just return that polyform. So let's go and have a look at the actual draw line function now. If I go to GFX, oh, why is that plopped me there? G3. Come on, Visual Studio, your navigation is appalling. What's going on? PG3, GFX, give me a function. There we go. Draw line. So this is the actual draw line function that the user calls. So we can see we pass in a point, pass in another point, pass in a colour, but it goes away and uses the generate function to generate that draw line and places it in the queue. That's all this does. It's simply a wrapper for go away and generate this geometry and place it back in the queue. I'm just looking at the generate draw line. I might have spotted a bug. That's why I'm just stalling for a minute. Let's go and have a look. Oh no, I haven't spotted a bug. Right. I added an interesting feature, and I've not seen this before, but once I did it, it made so much sense that I assumed everybody does it this way. If you've got your own sort of transform class, and I do, I have this affine transform class. Sometimes your transform class will have a function in it. Let's have a look. Let's go and have a look at this one. I'll expand that out. So typically, if you've got a transform class like I do, so it takes rotation and offset, a zoom, and all that good stuff. You take a two-dimensional vector and you want to manipulate it, you want to transform it by the transform, you multiply the two together because fundamentally the transform is represented as a matrix and sort of blah, 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 blah. You're following. Most of the time, though, you never want to call it on a single point. So I went a little bit modern C nuts and actually thought, well, why not just pass in a whole set of points and get it to just go and transform the entire vector of points in one hit. And it turns out I'm using that all over the place because it's far more convenient to transform the whole lot of vectors rather than iterating through them one at a time. Obvious to some, I'm sure, but it wasn't obvious to me when I set out on this, and now I'm using it everywhere. So you'll see this sort of pattern quite a bit. And that's where the device transforms handle. So you see all these fancy panning and zooming and rotates. That's because the geometry sent into the drawLine function is transformed at that point. So you'll see drawLine calls the polyformer function. This is in the generate function. And ultimately, that decides where it wants to go. And why do you want them to be separate? Because I might want the user to call the generate functions, as they do in here, if you don't actually want to draw the geometry. And I thought that was a nice way of keeping a separation between the two. So all the functions still exist. They've all got one-to-one parity with non-just generative ones and should work together. Anyway, it's a bit of a pattern. Got a profile why it's slow. Guessing doesn't get you far. That's true. At the moment, I think it's simply there's a lot of vector-to-vector transfers going on. Mainly because I've got to get it into Pixel Game Engine 2. Pixel Game Engine 3 doesn't necessarily have to have that restriction because I could store the data in a format amenable to graphics buffers in the first place. Of all the pet peeves I have, the worst one by far, pick apart and the variables name, 2 or 3 only, the original author knows. Yeah, I don't tend to do that. In fact, I get criticised for having overly verbose variable names. For the more modern look, I'm not that bothered about looking modern, to be honest. It's great having all that stuff and then realise suddenly I've alienated half of my audience because they don't actually understand that yet. So I agree. It's a tough call. Sometimes you want to look dead modern and posh, and sometimes you don't. So as you can see, we've looked at a handful of functions here, but I think this method of creating geometry and shapes is for me kind of sticking, and I found it quite easy to go away and achieve the effects I wanted. But then I wanted to get clever, and that's where things started to fall apart. So if I take my circle function, one of the properties of the circle function, I think it's the last one here. Of course, my circle isn't some infinite circle. It's just a fairly high resolution. By default, it consists of a fan shape with 128 edge vertices. That's if you zoomed in enough, you would start to see them. And I'm happy to accept that compromise. I'm not making some perfect renderer for that level thing. I think if you're drawing a circle that's so massive on the screen, you probably want to think of a better way to do it anyway. But one of the byproducts of having this resolution, of course, is you can specify a low number and have a regular polygon created instead. Let's have a look at this. So there's our regular polygon. It's now a triangle, and of course if I press A, it should behave in exactly the same way as before. So the stroke function goes away and tries to sort of outline the shape, and I've realized there are some bugs in my stroke function, so I've got some things I want to iron out there. So that's quite nice, right? You get all of these other regular shapes for free just by specifying that resolution. Simple stuff. Why is this important? Well, because if I use a low resolution, we can start to see how a few things work. Let's pull back a little bit on these shapes. So if I wanted to go back to stroking, we'll just leave it as the default for now, exactly as it was before. Let me just make sure I understand what that looks like. Right, so I think we've got our regular, there we are. So I changed it to 5, we've got a pentagon, and it's behaving as nicely. What I thought is, well, actually the stroke that is returned is just another polyform. So what happens if you stroke a stroke? And it actually becomes quite complicated. And that's what I was starting to work on yesterday on the Discord. In fact, Ali and Channel Mouse on the Discord were helping me work out some formulae to iterate through the geometry. Why is it complicated? Well, let me pull out Dazzle. I want to go back to stroking. Yeah, I've got to be kind of careful with some of this stuff now, I suppose. Have a look. If we wanted to, yeah, I've just dazzled everybody. I know, get over it. Stroke currently works like this. So when we drew the circle, what's actually generated is called a fan. Right, so you got your edge points. I think we had just 5, and we then create from this a whole bunch of triangles. So this is what the geometry looks like. Right, something like that. It's a bit crude, but it demonstrates the point. And what the algorithm does for stroke is it looks at a point on here, effectively calculates a normal for that point, and a normal for that point, and joins them together as a pair of triangles. Right? This is a simple stroke, so this isn't radiused in any way. It's purely pointy edges. We could have scope for all sorts of interesting effects. So we do the same here. We create a normal, and we join those points. And you can see we start to create what's called a strip. It happens to go all the way around the shape, but ultimately it's actually a single strip. So if we now take away the original shape and just leave ourselves with the stroke geometry, it's no longer a fan. When we actually want to create a stroke of the stroke, we now need to sort of look at these points and take the normal there and join them together. But, as you can start to see already, you get these sort of interesting non-uniform thickness problems as a result of how you calculate that normal. But also the vertex ordering is no longer a fan anymore. It's actually quite tricky to work out what the ordering should be. So I've started to work on some equations to do that. There's another problem as well, that if you are stroking a stroke, let's say we've got a stroke now, I'm not going to colour it in, but fundamentally the stroke in geometry form looks like this, around the edge of our circle. So it's still a strip. I have all these sort of sections in. And each of these sections will comprise of triangles. What is the right solution to stroke this shape? Well, you can assume there's like an infinitely thin gap going through, but you want to start creating then a stroke around this edge. But this has to be a single strip, not 2 different polyform objects. So we go around that edge, then you want to break through there without drawing anything, and then go around that edge, which is absolutely not the same as how you would go around the edge of a fan shape. So it turns out you need a sort of unique stroke implementation for all of the different geometry primitives, shapes in the background. There's only 4 different shapes, but you need to think about all of these differently. And you also need to think about what happens in this situation. There's an old trick you can do with polygon strips by all of these will be sort of clockwise triangles that we're creating, and if you want it to be invisible, you can create a sort of counterclockwise triangle. So you've got to make sure that going across this bridge, your triangles are out of order in terms of clockwise rotation, to make sure that you don't actually draw the stroke through that bridge, and you end up with this nice sort of dual circles of strokes, but it's actually all just one set of geometry to call. So there's some complexity there, and that's currently the problem I'm trying to solve. It's a fan pun here. Stroking streak. Oh, there's all sorts here, isn't it? Oh, an anonymous gifter gave Fractal Mind Dev tier 1 sub. Well, thank you for the anonymous gifter there. So that's what I've been up to. I might think about releasing a little bit of Pixel Game Engine 3. It's a little bit tricky because I'm also trying to comment it up as I go. Even my extension here for Pixel Game Engine 2 actually does steal bits from the Pixel Game Engine 3 implementation that I've got, not just by copying them in. So it's a bit tricky to distribute. It's all, at the moment, I'm just trying to feel out these ideas and see how they work. I'm sticking with this approach because it's worked very well for me. It's become quite intuitive. But I think now we need to go back to the editor, all the way back to the original, because we've changed the nature of how some of these functions will work. And I just want to make sure that I've got cohesion between this sort of strange Pixel Game Engine 2 implementation and the final version, so the shock isn't too much when I swap between the two. Header combining tool to the rescue. Yeah, I think we're going to have to dig that out and maybe make some improvements to it. Ultimately, we're going to need to do that anyway. So there we go. That's what I've been doing over the last few weeks. You can see I'm not just sitting around doing nothing. I might not be streaming very often, but I'm still trying to get the code done when I can. And we'll get back to, now we've implemented transforms and I've implemented polygons and textured polygons, I can actually get back to the whole point of this particular exercise, which was to do some animations via the medium of a transmorph. And until then, I'll see you later. Bye-bye.